Hey, this is Rotom Tech here, and we're just gonna look at the second question here. And this is subsequence on easy difficulty, and we can see that given two strings s and t, we just have to return true if s is a subsequence of t, otherwise false. And we can see a subsequence of strings is a new string that is formed from the original string by deleting some, can be none, of the characters without disturbing the relative positions of the remaining characters. So we can see, for example, ace is a subsequence of A, B, C, D, E, while AEC is not. So in the question, what it tells you is that first, the subsequence has to be in order, right? So it's the same letters here, ace and AEC, but this is not a subsequence because it is not in order. And second, S can be empty, so we gotta account for that if we have to. So going through the examples, we saw this one, but there's an example here. For example, S is ABC and T is abgdk, and the output is true. And we can see example here. It's AXC for S, and there's no X in T, so it should be false. So what's a good way to go on about this? I'm already thinking that when we have S and T and we kind of have to check if something's in order, we can kind of use two pointers while iterating through the longer length string here. So for example, when we're going through iterating through T here in example 2, we're going to check, we're going to have two pointers, and if it matches, right, for example A and A here, the first letter, then we're going to move the pointer up one on S, and we're going to iterate through T regardless. So we can show that in action just to show what I mean here. So we have, let's get the two pointers right here. I and j is 0 and 0. So obviously it's going to start at the beginning of the array or string. And we're going to see this by putting a while loop. So while I, so I is going to be the pointer for the string of s. So while I is less than s, and j is less than t. So while we're doing while of I and j, what's actually just going to happen is we're just going to iterate through j, and this pointer is only going to go up if we meet a certain condition. So in terms of iterating through, we're only really iterating through this and no more than that, right? So just to show what I mean, we're going to put the conditional. So if I or s at I, so if this pointer is equal to t at j, if this is met, so if the characters are the same, so we're checking if it is a subsequence, right? Then we're gonna increase the increment I here, which is the pointer for s, right? And it's important that we increment the smaller string, so the subsequence, right? Because we're checking whether it is a subsequence of t, not the other way around. So if I incremented j instead, this wouldn't work because this we're not doing it the other way around, and t is just too long for s, so it wouldn't be a subsequence right off the bat. So it would we would get some kind of error, and it wouldn't be correct. So knowing that, so whether we have met the condition or not, we're going to increment through j. So while we have while we have I and j like this in the while loop, we're only ever incrementing through j's and no more than that, right? So while we do that, this is pretty much the bread and butter of the code example here. So we just have to return the correct value. So we just have to return a boolean of true or false, and we can see that if we were able to iterate through all of s, right, then the pointer would be at the end of the string. So that would mean the I would have to equal the length of the string. And if it doesn't, so if the statement is not true, it will return false, right? And this accounts for both the position of the string. So this has to be in order, right? So because how the pointers work, going from left to right, you're always going to be in order in this code example here. And we're also going to account for whether s is empty or not. So for example, if s is empty, we're going to start at point 0, right? that's just natural where the pointer is going to start from the left to right. And this condition will never be true because they'll never match because S is empty. So therefore at the end, 0 is going to equal 0. So if S is, for example, empty in a test case, it's going to return true. So we're going to account for those edge cases here. So we're just going to hit run here, see if it works. Let's see. And there you go. It should run. And the runtime is pretty slow, or pretty fast. I said the wrong thing in the first video. So anyways, let's look at the example here. So in terms of time complexity, we're going to run through O of n. Like I mentioned previously, we're only iterating through the length of t here, right? Because this is just a pointer, and once this is true, right, once we get to the end of this, we're going to return true. So O of n time, where n is the length of t, right? And for space, it's just going to be O1 space, right? Because we're not really taking up space. I mean, we're making these pointers, but they're going to be constant no matter what you do. It has no relevance to the length of the strings of S and T, for example, right? So this should be the answer for is subsequence. Thank you so much. Hope this helped.